Hey everybody, it's Mr. N, and today we're going to talk about properties of special parallelograms. So now, when I'm talking about special parallelograms, these are special parallelograms: a rhombus, a rectangle, a square. Now, a rhombus is a parallelogram, and here's what's special about it: it's got four congruent sides. A rectangle, parallelogram, and here's what's special about it: it's got four right angles. Now, what if you had something that had four congruent sides and four right angles? Well, then that would be a square. A square is a parallelogram with four congruent sides and four right angles. So basically, a square is a rectangle, right? Because it meets the properties of a rectangle. But a rectangle is not a square, because a rectangle does not have four congruent sides. A square is a rhombus because it has four congruent sides. But a rhombus is not a square. So a square is both of these, but neither one of these is a square. So there's like a hierarchy. You have a rhombus, you have a square, and this will fit the definition of each of these. And because of that, in the hierarchy, this is both of them. So basically, in the hierarchy, you've got parallelograms, right? Or you've got quadrilaterals. And then you've got parallelograms as one type, and then under that you've got the rhombus and the rectangle, and under that you've both of these as a square, because a square meets both of those definitions. So based on this, here's our next thing that we're going to talk about, which is this rhombus corollary. So if you have a quadrilateral and it's a rhombus, we say if and only if it has four congruent sides. So it works either way. If you've got four congruent sides, it's a rhombus. If it's a rhombus, you got four congruent sides. Same with a rectangle. If you've got four right angles, it's a rectangle. If it's a rectangle, then you got four right angles. So that's why we're saying that if and only if. And then finally with a square, we could say it works both ways. If you've got four right angles and four congruent sides, it's a square. If it's a square, then it has four right angles and four congruent sides. And remember what I was talking about with the hierarchy? Here it is in what we call a Venn diagram. You've got parallelograms, and then you've got a rhombus, and you've got a rectangle, and a square encompasses both. All right, let's take a look at what we got next. Over here, let's enlarge this. We've got a rhombus diagonal theorem, and on this, a parallelogram is a rhombus if and only if, again, this works both ways, the diagonals are perpendicular. So if you have perpendicular diagonals, you got a rhombus. If you got a rhombus, then the diagonals are going to be perpendicular. So in a rhombus, you need to memorize that the diagonals are perpendicular, and if you've got a quadrilateral with perpendicular diagonals, it's a rhombus. Rhombus opposite angles theorem. Okay, so you have a parallelogram, and you know it's a rhombus if and only if, again, it works both ways, the diagonals bisect a pair of opposite angles. So this diagonal right here going down is going to bisect the angle. This diagonal is going to bisect the angles. So as long as the diagonals bisect the angles, you got a rhombus. And if you got a rhombus, the diagonals will bisect the angles. Look on a square. It's obvious that this angle is smaller than that one. So you notice how the diagonals do not bisect each other. Or, I'm sorry, rectangle. Whereas on a rhombus, they do. Because a square is a rhombus, these properties will work on a square. The diagonals of a square will be perpendicular. The diagonals of a rhombus will be, or the angles, these opposite angles, will get bisected. And then a parallelogram is a rectangle if and only if. So here's the property of a rectangle that we're going to memorize, besides the fact that everything else, like a parallelogram, opposites parallel, has four right angles. These diagonals only in a rectangle will be congruent. Okay, the diagonals will be congruent. And not only that, we know that it's going to bisect them, so these two parts will be congruent, right? And those two will be congruent as well. So there's quite a few things we've covered, and here's a couple more. Here's a couple more theorems. The midpoint of the hypotenuse of a right triangle is equidistant from the three vertices. So here's what I'm saying on this one. If I have a right triangle and the midpoint, we're going to talk about this more later, the midpoint of the hypotenuse, so here's the midpoint, and we've kind of done this already. This is going to be equidistant from the three vertices. In other words, this, and that are all congruent. If an angle of a parallelogram is a right angle, then we know it's a rectangle. That's what we've talked about. And if two consecutive sides of a parallelogram are congruent, then it's a rhombus. So in other words, if I've got these two sides and I know that it's a parallelogram and these two are congruent, there's no other way, as long as it's a parallelogram, to keep this parallel, to keep that parallel, other than making these congruent as well. So you end up with a rhombus. All right, so in class we have a lot of examples we're going to be doing, but right now let's do these few examples here. On this first one, if AD is 13, so A to D is 13 here, then AB, and now we're saying if it's a rhombus, then AB will also be 13. If the measure of angle 4 is 25, then the measure of angle 5 is also 25, because the diagonals here will bisect the angle, assuming that it's a rhombus. Now, if the measure of angle DAB is 130, then ADC, well, we know that these are going to be supplementary, so if we dab at a 130-degree angle, then ADC will obviously be 50 degrees. Okay, if the measure of angle 1 is 5x, let's erase some things here because it's kind of in the way. So let's go ahead and erase this, and then we've got right here, if the measure of angle 1 is 5x plus 18, and the measure of angle 5, so this is 5x plus 18, and the measure of angle 5 over here on this side is 3x minus 8, and this one on this side is 5x plus 18. Well, if it's a rhombus, we know that 1 and 2 are the same. We know 4 and 5 are the same. So I can say this angle, A, right here, this full angle, plus the full angle of B, they're going to be supplementary, right? Because it's a parallelogram, it's a rhombus. We all know that. So that means 2 of these 5x plus 18s and 2 of these 3x minus 8s together have to be the 180. So let's go ahead and solve this. So this we end up with 10x plus 36 plus 6x minus 16 equals 180. So 10x minus the 6, or plus the 6x is 16x, and 36 minus the 16 will give me plus 20 equals 180. Let's finish it over here. Subtract 20 from each side, so 16x equals 160. X will be 10. All right, on the next one, let's go to the next page. We know that it's a square, so and here's our next page. We know that it's a square, so let's go ahead and answer these questions. If M to J is 12, then ML and LK, those are also going to be 12 as well, 12 and 12. Okay, if J to L is 18, then M to K is also going to be 18 because it's a square, so the diagonals will be congruent just like in a rectangle. If MK, we said 18, and then JX here, sorry, is going to be 9. I forgot the rest of the problem. And XK will also be 9 because remember, in a parallelogram, the diagonals will bisect each other as well. So that all those properties hold true. If the angle of MJK, and MXJ, okay, so if this is a square, that's going to be a 90-degree angle, and the diagonals will be perpendicular, just like in a rhombus, so that'll be a 90-degree angle. All right, next over here, this is a right triangle, and RQT, and QS is a median. Okay, so that means it goes to the midpoint here, right? So that means we just learned that this piece will be congruent to that piece, which will be congruent to that piece, because the vertices from the midpoint of a right triangle are congruent. So if S to T is 8, then that means Q to S will also be 8. If Q to S, let's erase this now. If Q to S is 12, then R to T will be 24 because each of these will be 12, right? And 12, so it'll be 24. If the measure of angle T is 55, then the measure of angle SQT will be, well, since these are congruent, right? That's the midpoint. That's an isosceles triangle, so that's going to end up being 55 in there as well. If the measure of angle T is 65, so let's erase some of these things to get them out of the way. Let's do that. So now we have the measure of angle T as being, let's get a different color in here. Okay, the measure of angle T is 65, so right in here is 65, then RQS, this one in here. Well, I know it's a right triangle, so that means this angle is 90, that's 65, so I can solve for this one, and that'll give me 25, right? 25 and 65 give me the 90, and if angle R is 25, then this angle right here will also be 25 because we have an isosceles triangle. And then if the measure of angle R is 35, then RQS will also be 35. Now, on the next one, I'm going to have you guys do it in class real quick. And it says, do it in groups. Show that the diagonals of square are congruent perpendicular bisectors of each other. So basically what I'm asking is the diagonals of this, and let's do it in this color, this diagonal and that diagonal. We need to show them that they are congruent and they're perpendicular bisectors. So I need to find, and I'll give you the hint on how to do this. First, you need to find the slope of each, right? The slope from F to H, and then the slope from E to G, and make sure that they're perpendicular. Next, after you do that, you'll need to find the distance from F to H and make sure that it equals the distance from E to G. Okay, so those are the two things, and you'll do those in class, and you'll see that these are, since it's a square, that these are perpendicular and the distances are congruent. So I'll stop at that. Thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.